Welcome to IFERP, a forum where innovations and research interest could be supported and developed, prioritizing our mutual interest. In this video, we want you to dive into our world, giving yourself a clear insight into IFERP. But first, who are we and what do we do? Institute for Engineering Research and Publication, IFERP for short, is one of the world's largest non-profitable professional associations operating under the Techno-Elite Research and Development Association, TRADA, meant for research and development in the field of engineering, science and technology. We are one of the largest professional bodies for engineering professionals in India and across the globe, established in 2014. We extend to every part of the globe, with more than 28,000 professional members and 34,000 student members. Our growing membership at IFERP has led to an increase in members from Europe, Asia, Australia, Africa and the USA, fostering networking opportunities that strengthen ties within and across countries and technical communities. The mission of IFERP is to connect professionals at an integrated platform for growth to divert knowledge and skills towards the sustainable application of professional education and more. And our vision of digitalizing innovation processes through our professional networking services and more has pushed us forward to our achievements today. With our mission to make our academic services reach the top and grassroots level of institutions, we are funding colleges to organize conferences and scientific events, enabling researchers incubated at different areas of our country to directly contribute towards the transformation of India. IFERP simply connects engineers, exchange global innovation, and acts as a bridge between researchers and academics by organizing international conferences, world conferences, faculty development programs, webinars, seminars, providing membership, and more. Some of our conferences include WCASET Malaysia, WCASET Jakarta, ICAS ETAM APU Malaysia, and many more. We've also organised scientific events in association with renowned universities done in the past, with over 28,593 journal publication services, creating opportunities to get your research paper published in high impact factor journals such as Scopus Indexed, Web of Science, Google Scholar Index journals, ESCI, UGC approved, L Compandax, ISI, Shimago Index journals, and many more. To make our operations smoother and more perfect, we have been supported by our associated organisation, Association of Cloud Technologists, Global Association of Nanotechnology, International Association for Big Data Analysts, International Association for IoT, International Wireless Network Association, and World Association for Structural Engineers. We have also worked alongside several clients and partners both nationally and internationally like University Malaysia Sabah, APU Malaysia, UNJ Jakarta, MC University Thailand, Ajman University Dubai, PUP Philippines, IIUM Malaysia, ISU Philippines, FCPC Philippines, WCC Philippines SRM University, Galgotia University, Amity University, and much more government and private organisations in different countries. At IFERP, we believe that there's always a better way to treat professionals, and that is what we do. If you would like to see more or go deeper on IFERP, you can visit our website at www.iferp.in.
Hello everyone, good afternoon. Welcome to our webinar series on PhD end-to-end assistance and guidance. Welcome to all our attendees who have joined us today. And I would also like to welcome our speaker who's online over here. Welcome, sir.
Yeah, thank you.
So today we are moving on to session 2, where we'll be discussing on transitioning from coursework to doctoral capstone writing. And before we begin, I would like to introduce to you our speaker of the day, Dr. Jagdish Wengla. He is head at EDC Innovation and Incubation Center, and he's also an associate professor at Department of Civil Engineering, PVP Siddhartha Institute of Technology, Vijayawada, Andhra Pradesh in India. He was also a former HOD at Department of Civil Engineering at BMSIT NM and at Bangalore. He was also the former Chief Coordinator at Innovation Center at BMSIT NM, and he was also a former scientist at MOEF Government of India. And he is also a former designer engineer, Torsil Research Foundation in India. He has delivered more than 130 invited and guest lectures at various national and international forums. And he has also chaired and co-chaired more than 20 sessions in international and national conferences. He has been also organizing several workshops, seminars, conferences, training programs. He has also published more than 35 research papers in various international and national journals, as well as international conferences. He has guided more than 25 MTech and BTech thesis students, and he has got more than 19 years of experience in research, industry, and teaching. He was also a recipient of Outstanding Faculty Award in the year 2019 by Venus International Foundation at Chennai. And he was also recipient of the 5th CIDC Vishwakarma Award under the category of Achievement Award for Scientists for the year 2013. Thank you so much, sir, for joining us today.
Thank you for introducing me. Shall I start the session?
Yes, sir, sure. You can begin.
I'll just share my screen. Yeah, hope you can see my screen.
Yes, it's clear.
Yeah, thank you. So next 1 hour, 1.5 hours, I'm going to give you some kind of overview how a researcher journey from coursework to doctoral thesis writing. So this the presentation, maybe I'll take some of the examples of my own work, and also I'll start with what is research, and then I will touch upon some of the very important key aspects of the doctoral thesis, starting from the coursework to doctoral capstone, right? So coming to the what is research, all of you know, whoever is a researcher, you either have to analyze a lot of data or the information you collected to understand about the phenomena or the process which you are interested or which you are concerned. There are a lot of definitions, but when you take up a research problem, first thing what you do is you take up the subjects related to that research, and those related subjects you take it up as a coursework. During the coursework, you will try to go through the research related subjects, all the fundamentals related to your research. Because when you start taking a hypothesis or a problem, to prove it, you need to be thorough with the fundamentals. So you have to put a systematized efforts to gain the knowledge. Research is nothing but gaining the knowledge. And after gaining the knowledge, you have to transfer that knowledge to the society. And in the process, you do a careful investigation through search for new facts, whatever branch you have selected, either science, engineering, or whatever technology, the research problem you choose. And there are few points you need to understand in the doctoral research. You have to take some of the independent decisions and you have a lot of independence while taking up the problem and converting that problem into thesis form. So you are also responsible. So you cannot, go in whatever direction you wanted to go. So supervisor will monitor you and suggest you and advise you in a right direction. And your research work, your doctoral research work, should have an original content. The problem, whatever you have taken and you work on, there should be originality. And end of the research problem, end of the research, the solution or the work you have done, it should contribute to the knowledge in the given field. Very, very important. And then the work, what you have carried out, it should be suitable for the publication. And you have to properly plan it from the beginning of the coursework to the end of your thesis submission, and even the execution also you have to take care very well. So you have to clear your objectives of your research in the first, so that whether these objectives can you able to achieve, you have to discuss with your supervisor and along with the domain experts in that particular field what you have chosen. And you also have to identify the importance of the problem what you have taken, and is it really relevant. You cannot take whatever work that has been carried out already, and if that particular work doesn't have a relevance to the society, end of the day, whatever work you carried out, it should be useful to the society. That's why we do research. So research outcomes should contribute to the society. So you have to identify that your problem having the current relevance or not. And you have to give enough justification. And you can ask yourself, why we have to do this problem? Or why to do it? Does it, give proper contribution or proper results? Or is it helpful to the society or the surroundings, your research outcomes? You have to justify. And you have to read a lot when you are doing the literature review. But it is very important. Anyway, the literature review, few slides I'm going to talk about after this slide. And to tell you, the well-defined problem is half solved of your thesis. So if you take up a well-defined problem, that means half of your research work is done, half of it is solved. So that's why you have to be carefully plan and execute your research work. And coming to the how to solve, so you have to look into your surroundings of your research area. You have to see that whatever the existing methods that are currently available to solve the problem in the same area, you can apply. You have to check it out. And can you be able to borrow different methods which are practiced in related or unrelated fields? That means, why I'm telling, it is like, some method which you are applying in the field of biology, that methodology can be taken, applied in civil engineering or applied in mechanical engineering. What I mean to say is you need to thoroughly understand the methodology that are being applied or the existing methods that are there, either in your field or either related or unrelated fields. If you don't find a method, you have to go for a new approach for solving the problem, and you should develop a new method or new approach. Finally, the method, whatever you have identified, you have to see that is it appropriate to solve the problem, and also is it adequate you should find out. And to do all this, your fundamentals must be sound, must be thorough. This is very, very important. That is why you brush up, taking up the coursework. Those are the subjects related to your field, so that all the fundamentals will be brushed up, so that you can apply the fundamentals and knowledge to carry out your research problem to get into a useful output. So you have to also, when you are doing analysis, so once you got the data, when you're doing analysis, you have to properly check the data. So is there a problem with the data? So, a lot of data analytic methods are available. So whether all the data is useful, shall we have to neglect or remove some of the data which is not appropriate? So for that, you have to carry out appropriate analysis to come out with a proper data sets which are useful for your thesis writing. And you have to perform a lot of checks while doing so. And some of the assumptions you have to make it, some of the model assumptions. And also you have to follow unexpected features of the data. So you have to see that it is properly taken into account. Anyway, I'm going to explain some of the things with the proper examples. So I'll go by step in explaining, giving some of the examples. Step one in the research, a question occurs to or is posed to the researcher, wherein if a researcher has no answer, it has to be converted. That means that particular question raised or the posed is converted into an appropriate problem statement, so that it will become one of the research problem. And then you have to keep on posing a lot of questions. Those will become the list of your problems in your research proposal. So those problems are discussed with your supervisor and then put into a proper form and convert those into research objectives of your study. So I'll give one example. Taking my research problem, that is seismic response study of bamboo-based construction. I'm basically a civil engineer. When I'm doing my doctoral thesis, I have considered a topic that is bamboo-based constructions, which are more prevalent in Northeast. So I've taken that topic, and then I have conducted the earthquake resistance of these buildings. So before that, any problem, you have to do the background study. Very, very important. So when I have carried out the background study, the houses, I have carried out the study on this particular bamboo-based house. This house has been already tested on a different method. That means there is a shake table wherein they've tested this building for the seismic performance. For that, they've given a lot of earthquake input. They've checked the fatigue of this building, and they've tested giving a lot of input of various earthquakes. But at the end of the day, this building doesn't exhibit any crack or distress. So this is a background study. Based on that background study, we understood, can we carry out the study on the same building till the damage? But when we checked, there is a cost constraint, because to test one building, it costs almost 5 to 6 lakhs. So if you have to check for 3 to 4 models, your cost is a problem. And also, can you able to replicate the same sophisticated facility at your place? No, because the facility costs you 1 crore, more than a crore or more. So what we have done, we have found the alternative to this particular method of testing. And also, end of this program, we could not able to assess any vulnerability of this particular building. So to address, when we study the background work of this particular building, check for seismic performance, these are the 3 points we observed. One is cost constraint, you cannot do repeated models there. One is you need a sophisticated facility, and also end of the day, you could not be able to assess the complete vulnerability damage of this particular building. To address all this, we have, that means these are the problem gaps. So these problems are converted into your objectives. Like cost constraint is taken care by creating a facility which is within 5 lakhs. We created the facility so that you can test number of buildings, number of models, and also you can test it till the damage. So what I mean to say, you have to do thorough research when you take up any kind of problem. So you have to do the background study, you have to find the gaps. Based on the gaps, you have to come out with the new research problem. How to choose a good problem? So there is a feasibility interest diagram for choosing a problem. So here you can see this is a x-axis and this is y-axis. X-axis you have like hard to easy, and then y-axis if you pay small gain of knowledge to large gain of knowledge. So initially, that means if it is a hard problem, you get a small gain. So how you have to go about it? That is very important. So you have to always start your problem with beginning of the problem with easy and gain of knowledge very small. So you have to convert your problem into a number of small topics, and then easy part you have to carry it up, and then you have to go along, you have to move with the large gain. That means long-term plan of the work, which is hard, but you will get a good outcome. And very important thing, within my example, my thesis example only, I will explain you how to take the problem. So you have to formulate a broad framework and broad research objective. Framework is very important. At the same time, your research objective is also very important. So the topic, as I mentioned, for my thesis, it is seismic response study of bamboo house using shock table. As I mentioned, shape table, background study, I mentioned the problems and why we chosen this particular small table. Choosing the table, so I have divided the entire problem into 2 sets. One is component level of testing of this building. That means whatever material you use in making the building, we are checking each and every component of that building. That is one level. And the second level is after making the building, so we call it a system. We created a system. So system level of testing of these houses carried out. So broad objective if you take component level and then system level testing. And then this has to be converted into a broad framework. How do you do that? So again, component level, I have done the property finding of the material, and then performance studies of the elements, and then analytical studies, and then in the system level, you have to characterize the table and then find out the study on the table by mounting full-scale house models. So this is how your entire research problem is divided and make a framework and with the broad research objectives, very, very important. So that is, the first step. How do you choose a problem? How do you do the background study? And how do you divide into framework and research objectives? And then, usually researcher generates an intermediate hypothesis to describe the solution to the problem. So that means you will feel that this solution or this hypothesis, what I have made, may be the solution to the problem. Because you're making a hypothesis, so you feel it is a best temporary solution. But after doing number of studies and deliberations or presenting, so people will either accept or reject your hypothesis based on your study. So if they accept, that means whatever, if they accept or the problem, what you have solved is accepted by most of the researcher in your field. So your hypothesis is good. Or otherwise, if they say no, this may be good, but there is another simpler method wherein you can do it. So again, you make changes to your hypothesis and again you present it. So making a hypothesis, suggesting a hypothesis is very, very important. At the same time, it's a best temporary solution. You have to go ahead with that hypothesis, and then based on your acceptance or rejection, you have to go to the next step. Coming to the literature review. Literature review is nothing but the process of reviewing the work of others within your field and using that as a base. Based on the work already carried out, you will find out what are the gaps that are there in your subject area. So, and the chosen topic, and then those gaps, converting those gaps into a research problem. And the available literature you have to review and find out if there is a solution to your problem. But existing solutions, it may not explain all the observations. It may require some revision sometimes, or it may be discussed. So you have to go ahead with a new way of problem finding. The solution finding. And why we do the literature review? Literature review is the most important part in your thesis writing, or your problem choosing, or your problem solving. So why do we do the literature review? Is there any existing work that is present in your field of work that gives a lot of information? And as I mentioned, based on the literature review, you can identify the gaps. And you can find who are the people working in your area. You can identify what are the methodologies, the research techniques they have adopted. And is there any similarity or differences you can find from the existing and the proposed? And you can provide a overall context for your own research. And you can show relations between previous studies to your study. So these are all the important points wherein why you go with the literature review. And literature review will give you a lot of motivation, and you can list all the missed out topics. And also it will give you some kind of boost. Suppose you have come out with some kind of hypothesis, you will find based on the literature review, oh, this work has not been done anywhere. So the proposal, what I'm doing, is a novelty and first of its kind. And also it will give you some kind of direction that whether the problem what you've chosen or the hypothesis, can you able to achieve based on the others' work, you can have a kind of feeling or kind of, so based on that, you can have whether you can achieve the chosen problem or not. And supporting the literature, like how do you do the literature review? I'll tell you, Google search will give you only 5% of the research material, whatever available in your area, because Google search won't give you all kinds of the material or the literature that you are expecting. Only 5%, I can say. But you have to find the right journal articles. Within journal articles, you have to go through review papers and even the expert opinions, discussions, research papers. All these you have to follow wherein you will find a lot of information to your problems. Based on that, you can find out whether the chosen problem is already solved or not. Is there any new thing we can do or not? Sometimes, if it is an experimental work, you can also go through the government reports. You can go to the related websites, suppose civil engineering related housing. If you are working, you can go through Building Material and Technology Promotion Council, Ministry of Urban Development and Poverty Alleviation. So if you World Housing Report. So many things. So similarly, based on your related field, you have to go to the government websites and you have to find out what is there in those documents. So that also supports to your literature. Conference papers, patents, even the textbooks will give you the right direction. Sometimes if you stuck up somewhere and try to solve a particular problem, when you go through the textbook, you have a solutions wherein small problems if you need to solve. So it will give a right direction. And also you can even go through some of the monograms developed by the professional organizations, very important. Some of the branded international journals, this is related to civil engineering, wherein one can, refer some of the, the branded journals. Some of the Indian journals, this I'm pertaining to civil engineering, I'm mentioning. So some of the Indian journals which are famous in your area, you have to look into it. So your area of work chosen should be compared with both the international, globally, and also in Indian perspectives. That means wherever you are, whichever country you are in. And how to find a paper of your choice? As I mentioned, Google only gives 5%. By using keywords, you have a lot of open source material. So if it is very important, even you have to pay the fee, pay for the journals, paid journals. Sometimes if you cannot do it, if you are registered in a research center, your research center subscribes a lot of paid journals. Your digital library, you can go and access all the paid journals because you pay the fees to your research center. And even you can go to your normal regular library for the hard copies or digital library for accessing different papers related to your area. And it is also very important to register or to become a member to professional organizations wherein these organizations keep publishing a lot of books, articles in your own area, wherein once you become a member, you will get the copy of the articles or copy of the book wherein you can go through what is the current areas in which developments are happening or which are the people who are working in your respective area. And then when you do the literature review, when you take out a typical paper, the first thing what you have to do is two things you have to be very careful. One is abstract and conclusion. Based on abstract and conclusions, you have to come to a conclusion that whether this paper is useful for me or not. So don't go through too much because your title is chosen, your research area is chosen. So when you have to collect the literature, a lot of literature, you just have to quickly go through what is the problem using abstract, what is the objective, and then go to conclusion, what is the findings or outcomes. But each of the paper subtopic will give you, different things. Like title will give you overall overview of the paper, and you have other details wherein you can communicate with him, and you can see when the paper is received and when it is accepted, when it is published, so that you will have an idea when the work is done and when it is published. In the same time, is it like relevant to the current situation? You can find out the keywords, and then background and literature review will give you the gaps, and then objectives. Methodology will give you what are the methods he has followed, what are the materials they've used, characterization, what they will follow. Discussion will give you how he has discussed the problem outcome, and so on. And literature review will give you integrated information, whatever. And it provides a complete picture of main question. And also you can find the gaps. So if you take a typical paper, there's an example of one of the paper wherein this is the title. So you can see the author names, and this is where you find out the when it is received, when it is revised, and when it is accepted. When you're working currently 2020, you can see like this is the work carried out 4 years back. So is it relevant right now? So you can, and abstract will give you the overall picture whether your research problem matches with the paper or not. And then if you want to go through the others' work, because in introduction you will get all the basic researchers' work summed up in your introduction. So you can go back into the references, you can find the original papers wherein you get the basic work and the fundamentals which you are looking for. And then at the bottom of the paper, you can find the corresponding author's email ID, and then wherein you can mail him and then get the information, whatever you require. Usually when you start your research work, your supervisor will tell you, why did you write a review paper in your area? So people generally do, they take like 10 to 20 papers and then they rewrite and then put it. This is one of the paper I'd like to give you an example because he has referred 146 papers. The abstract is in 4 lines. In the 146 paper references converted into 12 pages of your review. This is the thoroughness one should expect if you do 146 papers thorough reference, I'm giving the example. So based on your research area, you can refer all the good quality papers in your area wherein you will come out with a good review paper. What I mean to say here is you need to do thorough number of papers wherein you come out with a good review paper. Yeah, these are the references. So one can go through. As I mentioned, like, suppose if you wanted to refer 2006 paper, it is there in the introduction. You can come back to reference and then find out this paper, and again you search for that paper and then get the basics of that particular problem. Very important. It is possible that the literature may lead to a solution to the proposed problem, but sometimes it may turn up nothing. So you have to carry out additional research activities to justify the review what you have done. And then step 5 is very important: collection of data, acquiring data, gathering data relating to your research problem. It depends, it changes based on type of your research problem. Sometimes you have to only collect the information. Sometimes you have to collect the experimental data. Sometimes you have to collect the data that is available in website. Suppose the temperature data, suppose weather data, you can get it in the website. Suppose earthquake data, you can get it in website. So data, and sometimes you have to go to an organization, government organization, wherein you can collect the data from them. It depends on your research problem. Again, I'm coming back to my research problem. So I'm working on bamboo-based houses. The bamboo-based houses are most prevalent in northeastern part. So what I did, I visited Northeast, made a point to visit Northeast, and then I have studied the existing house types in Northeast. These are the kind of houses that are present in the Northeast. Wherein, based on that, you can kind of come to a conclusion that these are the houses, this is the house I'm going to work, this is the performance. When compared with these houses, these are the modifications you have to do, so on. So what I mean to say is, with this example, you have to visit various places, sites, which are relevant to your research problem. Very, very important. I will give you an example from my master's thesis on a particular concrete 2001. It's a self-correcting concrete where I worked for my master's thesis. I visited, believe it me or not, for literature review. I was in Bangalore at the time. I visited Indian Institute of Sciences, and I visited Structural Engineering Research Center, Chennai, SCRC, and then L&T Chennai. I visited all these places, collected the data, and have seen the experiments that are carried out in that area. Based on that, based on the data I have collected, or based on the exposure, I have come to a conclusion that yes, I am going in a right direction. So you have to visit the various sites if it is an experimental work. If you are gathering data to check the data, you have to visit various sites and various places which are relevant. And also you have to find, suppose you have chosen a problem, because my problem is on bamboo house. I'm just giving my thesis as an example in most of the time. So you have to see whether this material is proven already. So is there any studies, like is there any long-term study about its performance? So in that case, one of the house in Assam, they've checked after 25 years, still it is intact, the material, bamboo material which I'm using. So the property of the materials have been checked anywhere else? Is there any long-term performance? Is there any durability of that particular material? So we have to find out, very important. This is very, very important. Is there any existing standards and codes that are there? If so, you have to follow these standards and codes for testing and generating the data. Otherwise, you have to come out with a new methodology which will become later part of the code or a standard. Very, very important. So when we found bamboo material till 2005, there was no mention about the bamboo. So first time 2005 they included bamboo as a building material here. So this is a National Building Code of India 2005, which is very important for civil engineering. Like, you know, Indian Standard Code 1, IS1 refers the standard for the national flag. Today is Independence Day, I want to mention that. So each and everything, every material, every product having a standard, having a code. So you have to give a lot of importance while testing, while testing a new material for a particular purpose, for making a particular product. If after making that product, for testing that product, if there is an existing code, Indian standard, if there is no Indian standard code, you can even follow ASTM or European standards to check the feasibility of that product. Very, very important. So we have to give a lot of importance to your standards and codes. So once you gather the data, you have to analyze, you have to come out with, ascertain its meaning. As before, the analysis of the data does not constitute this. So you have to do a thorough analysis of the data, what you have gathered, and is it useful further for your research work. And then you have to interpret the newly analyzed data and you have to suggest a conclusion based on the data. It can be difficult. But keep in mind, the correlation between two variables can't automatically be interpreted. So you have to see which data, so whatever data you have collected, based on how many variables are there, what is the relation between these variables, and come out with a kind of a statistical approach or a statistical conclusion. That is why data interpretation is very, very important. And then there are two ways of research problem in your thesis. One is qualitative and another one is quantitative research. Generally, qualitative is analysis. It's a descriptive kind of thing. So in form of words, pictures, based on objects, the data is there. And sometimes it is a meaning of experience, qualitative. It is more rich, there is more data is there, and then it is time consuming, very difficult to analyze. But quantitative is like you will collect, count, you construct statistic models, and it will be in the form of numbers and statistics. You can examine the relationship between these numbers, whether is it an independent variable or dependent. But quantitative is more efficient. It is able to test your hypothesis in very well manner. It is like, qualitative is like, okay, this is good. How good? This is 20% better than that. How? Based on your testing, based on your quantitative. That's very, very important. People are more towards, quantitative. The data will either support the hypothesis or sometimes not. It may lead research to cycle back, and you can begin a new hypothesis. Because once your hypothesis, you think it is not working at all, then you start with a new hypothesis. This is one of the self-correcting mechanisms with the scientific method based on the data analysis. Very important. And there's a clear difference between research method and methodology. Methods are which you conduct research into a subject or a particular topic. It involves experiments, tests, surveys to find solution to research problems. But methodology explains various methods where you proceeded, and it involves a lot of techniques that can to conduct the research itself, conduct the tests, experiments, and it aims at employment of the correct procedures to find solutions. But here, research methods of find solution to this. In methodology, you will find the correct procedure, how to arrive at a correct solution. And few points I will, over a period of time, based on my research work, I will give you some of the points. When you are doing your research work, your doctoral work, you need to understand and involve others in your experimental program. Very, very important. Involve a lot of people so that they will pose a lot of questions to you. Don't think, they will copy your work or otherwise, because some of the experimental, you require 4 or 5 people's support. So you have to, sometimes you have to, engage your masters, some of the master students, bachelor students in your research work, and you have to, ask your colleagues to take part so that he will also learn various instruments, equipments, how it works, and so on. You also please get involved into others' work. Very important. Sometimes you get some kind of idea based on their work, even though it is not relevant to you. So, can I apply the method which he is following to my work? That means even though both are totally 2 different research works. So sometimes you get a lot of idea when you involve in others' experimental program and make others to involve in your work also, wherein they can pose a lot of questions which will give you, a lot of insight into the problem. Very, very important. This is what we miss most of the time. The representation of the experiments, collecting the data. You don't do, you have to picture each and everything, photograph, document each and everything before and after experiment. So this is a treated bamboo. If you don't treat it, this is the untreated bamboo, and the treated bamboo, how it. So representation is very, very important. And how do you, represent, and how do you document? Many times what they do, they are more worried about, suppose if you are carrying out tests on some product. So researchers' inclination is more on, after testing, what is the value? What they do, they don't, focus on taking pictures for starting of the work, the procedure, to the end of the program. They don't do that. They keep the product, they test it. Finally, they note down what is the final value. That's not give you any kind of, anyway, it gives the value. But if you don't collect, take pictures of each and every stage of your work, the end of your thesis writing, you face a lot of difficulty in, you may have to, take pictures, fabricated pictures after the experiment, all the experiments got over. So what you will do, you will go to laboratory and then keep the sample on the testing machine and you take the picture and you show it in the thesis. No. You have to take the pictures while testing, before testing and after testing, and represent with evidence before and after experiments. Very, very important. And summary. What is that? Okay. The first part of my thesis, when I did seismic response study on house, the single element is bamboo. I have carried out all the tests on the bamboo, say compression, flexion, whatever number of tests. That has become one chapter. At the end of each chapter of your thesis, doctoral thesis, it is very important to summarize the work, what you have done in that particular chapter. 1 or 2 pages of summary is required for each and every chapter. Because when the thesis goes to reviewers, it is very important. They don't have time to go through each and every page of your thesis. Some people, they do it. But usually what they do, they go to the summary of each and every chapter of your thesis and then find out, oh, okay, this is what, okay, this is good, okay, let me check. So if required, they go through that particular chapter of particular method. So it is very important to summarize each and every chapter in your thesis. Very, very important. And then, so once, I'm just explaining my thesis work, wherein once I did one element, based on the, one material, that is bamboo, based on that we, cast a number of elements, like wall, roof element, truss element, so on. And then we did carry the studies of performance of these elements. So stage-wise is very important. When you do basic properties of all the materials, when it goes to the next stage, you have to carry out the performance, and then finally you assemble and then test it. So whatever the research area is, you have to go stepwise and check the performance at each stage. That is very, very important. Application-oriented research is very, very important, and it is useful for the society, and you will be happy within, because working for 4 to 8 years, it depends on 3 to 8 years. Okay, so working so many years and coming out with a good thesis, if it doesn't transfer into the actual application, whatever may be the application, so you don't feel good, because it's a culmination of 6 to 7 years of your work. So this is one of the part of my thesis wherein we tested and then implemented it. So when you are working on your thesis, you also think about this societal and application oriented. It's very, very important. Some of the, and then we tested the columns, and then the same, we implemented in one of the house. And then each and every testing we carried out for the performance, we made a big house. This is very, very important. One is for supervisor. See, when you come out with some kind of concept or a hypothesis, when you're solving it, you cannot just orally explain to your supervisors or the people saying that, sir, in air you cannot explain. Sir, this is that is that. So 3D visualization and representation is very, very important. If you can, create what you are thinking in a 3D picture, so your supervisor can understand, can give you suggestions, more suggestions, wherein that improves your research problem. And it converts into a good solution. Very, very important. So 3D visualization you have to bring in and represent properly. So when you either explain to your supervisor or your co-workers, very, very important while you are working for your thesis or a research problem. And when you are carrying out studies, you have to see that with the same system, whether they've used different materials. If so, what is the performance? I'll give you one example here quickly, because it's a generalized topic. I've chosen my thesis. So there is a Darji construction that they follow in Srinagar and other areas. In Darji construction, what Darji is a tailor what he does, he collect pieces of cloth and then he'll stitch into the bigger cloth. So similarly, that is our constructions. The house is made of timber frames. Within timber frames, they fit in the stones and other clay, unburnt clay materials. It becomes a wall. So because timber is getting scarce, so instead of timber, if they use bamboo in place, what is the performance? Somebody tested and they found that it is 3 times better than the timber. So you have to see, is there any other material or the material what you've chosen can be used for number of applications. Very, very important. And you have to find, so when I chosen, I showed you in background study shake table. So what are the alternative shock table is there? Is there any existing studies carried out? Yes, it is carried out at various places. So is it giving a good results? Yes. So based on what are the existing studies that are carried out using the same kind of instrument, equipment, or the method or the process, you have to find out. What are the existing studies? What is the outcome? Is it giving a correct result? To find out, is it proving well enough? So based on that, in my case, a lot of studies have been carried out on the masonry houses. So I've chosen the same table for testing the bamboo house. And then very important, see, you can see this is one model, this is the other model. Okay, so is there any difference between both the models? No, both are same. But these models we have carried out, tested both the models. One is to check, we've changed the labor and then we've built using with them. So if the workmanship changed, is there any change in the behavior? And we have also wanted to check the repeatability of the results. Very, very important. Repeatability will give you a lot of confidence. And also this particular model we have tested till the damage, the previous model only up to the 20 shocks. Also, once you finish your experiments, it is very important to give a symbolic representation. In my case, I'll give you, based on the picture, I have embossed into paintbrush and then converted this into a schematic representation. Very, very important. Giving a symbolic representation. Coming to some of the people, they take up experimental work, most of the engineering and science, technology related. You use a lot of equipments, you work in the laboratory. Very, very important to know what are the instruments that are there in the laboratory. What are the safety procedures you have to follow and how to use the equipments. Never ever use any of the equipment without knowing. So you have to know the procedures, SOPs, and how to operate. If you don't know, please learn. Personnel will be there. You have to let them do 2-3 tests. If you get confidence, then only based on the procedures you have to operate the equipment or instruments. This is the work I carried out at Colorado State University, USA. So wherein before that, I have thoroughly understood what are the equipments that are there, what are the safety procedures they have to follow based on, and that this is a very good lesson for all the researchers, very important. Any laboratory you enter, find out safety procedures and find out how to use the equipment. Then only you carry out your experimental work. Very, very important. This one more lesson I've learned, that you have to design based on availability of materials. Don't think that this material is not available. delaying your work. No, whatever available material is there, with that you have to design your research. So when I visited US for my Government of India fellowship, what happened? The bamboo that is available is thinner in nature, but accordingly I've designed the experiments and carried out the experiments. Sometimes when you are doing the test, suddenly it fails. In my case, I've built a wall when we, did the cyclic test. The base got failed. So that means we don't give enough fixity in the base. So for that, what I did again, so we created a fixed base. We've strengthened the base model. So don't get disheartened if an experiment fails. Report the same. Report the reasons. Never ever avoid any of the experiment what you have carried out. Discuss with your supervisor. You can put a line at least. So you're putting a lot of hard work in your thesis. When an experiment fails, it doesn't mean that you have to negate those results. You have to put a line. When you follow this particular procedure, when you carry out the experiment, these are the problems you may face. That will be a lesson for the future researchers who would like to carry out the work in the same area. They will not attempt that kind of work. Very important. Yeah, this I wanted to show it because a lot of websites, many times you collect data. In my case, I need to collect earthquake data. So one of the websites that is USGS, United States Geological Survey, Earthquake Hazards Program, will give you all the data related to the entire world. Whatever earthquakes happen, the data is there in the. So you just have to search that particular, earthquake, and then this is how the earthquake data file of Bush earthquake. Okay. So you will take the data, use it for river analysis. Similarly, sometimes people want the temperature data, or people want the atmospheric data, meteorological data. You have to go to the website to download and use it for your purpose. Very, very important. Most of the experimental works or the engineering or technology science problems, you need to use a lot of tools and software. It's very important. If the research, the pertaining research pertaining to your problem, which are the tools and softwares are required? Because if you start doing it manually, it will take years together. Okay. So there are a lot of tools and softwares that are available before and after the experiments, when you have to do the analytical models and to find out whether this model will work or not. Based on your previous research work, you can give the input to the model, and then you can see, oh, it is working. Then I can go for an actual model. So do the model, and then you can compare both the analytical model and then experimental model, and then come to a conclusion. Yes, this model fits perfectly, all right, before and even after the experiments. So this is what I have made a model of the house using different finite element software, and then we have found the fundamental natural frequency of the model. What we got is 13 hertz, 13 to 14. And this is very important. Whoever is doing the experimental works, you have to build working models. Very important. So that when you make the working model of your research work or the particular problem, so you will avoid a lot of basic mistakes. So based on the model, making the model, take to your supervisor and explain it. So he'll tell suggestions. You can. So when you're actually making a big model and testing it, so you can avoid a lot of mistakes. This is very, very important when you are whoever is doing experimental work. This is a photo I've taken when I visited Japan in 2009 to attend one of the world's largest shake table tests. I've represented from India, wherein you can see here the representation of each and every house and even the representation of the cracks. So you need to represent with various notations. Particularly, I will show you here. This is one of the wall wherein this is the first test carried out on 30th June. The crack for the first test we have represented with the red color. And similarly, second test carried out, and then the crack. And then, so this is how it is marked with a different color. So notations representing symbolic representation of various notations is very, very important. When you take up the research problem, many of the times, if it is related to the experiments and materials, people keep on adding to the scope. Scope should be defined very well. If you start telling, I wanted to add that material, you have a number of variables, like 10 variables will be there. If you need to do 10 experiments, and if you wanted to make 10 samples of each, 10 into 10, 100. 100 experiments you have to do it. Each experiment, 100 samples, 100 into 100. So always limit the variables. Very, very important. Your focus should be, you have to define the scope very well. Define your scope with the materials available. And then some materials you can take it out, because when you carry out the experiments, a number of specimens will come out, and then when you test it, a lot of data will come out. So number of variables, it will become a clumsy. So you have to define the scope very well. People will neglect many times in most of the research works. Sometimes they even neglect the small detailing. An example: this is a particular prefabricated house, steel prefabricated house. So what study we have carried out, you'll get surprised. The steel frame is connected using different bolts with the sheet. We've gone into the small detailing of the bolts. What kind of bolts can be used? So there are typically lug and hex bolts are available, and then one of the bolt gives more elasticity. That means more elastic in nature. So by conducting experiments, we found this bolt is better in case of earthquakes or whatever forces. So you have to give even the small things greater detailing, give importance. That's what I mean to say. And sometimes you have to collect the data. As I mentioned, these are the 4 kinds of houses we have collect data, and sometimes you have to use. I'm telling you, this is civil engineering building, civil engineering problem. We have actually started using sensors, collecting the data, IoT. So what I mean to say is, take the help of the technologies, then measure the technologies with greater accuracy, so that the thesis will become beautiful. So you'll get a beautiful results. So this is a comparison we have made for the different roofs. And even the coatings also we've changed. I'm talking about the variables. So here, different houses, the roof is the main the component wherein the heat gets transferred. Again, when you take only roof, roof is with roof different coatings, how the temperature, heat transfer is there. So here you can see number of variables. If you keep on changing the variables, you get a lot of data, and then finally you will come to a conclusion and a good output. And I will tell you the variations. Sometimes in some of the colleges, you don't get the available equipments. When you do the small work, initial works, you need not carry out by building bigger things. So these are the small house models created, and then we measured using this normal humidifier, temperature and humidity measurement. This is the initial measurement we have carried out. So after that, we realized like, okay, let us put data logger and collect the data. So that automatically collects the data. And after that, we built number of models. This is, the work carried out at various places, one particular topic wherein. So here, no one is there now. It is automatically, all that sensors we place. So this is connected to the Raspberry Pi, and then this upload to a server, and then we get the data, and then in the server it gets stored. We can even see the front end application. So we have, a conglomerating of different technologies to get the better output is very, very important. And whenever you take up comparing, you have to compare with the equal materials. That is what I wanted to mean. And the standard representation, standard notations, you have to show it, very important. So how do you test it? In which direction? You have to represent, very important. So when you're comparing with this this is the 12, this is the type, this is again you're comparing with wood with bamboo. So this comparison of equivalent materials is also very important. You cannot compare the steel pipe with the bamboo, right? So bamboo and wood both are natural materials also. As I mentioned, it is very important to associate with the laboratory personnel, very, very important when you're doing the experiments, because they know better about the instruments, the procedures, and the methods. It is very important to associate with them and then try to learn usage of all the basic tools that are there in the laboratory. Very important. You don't know when you need to use which tool for your experiment. Suppose the instrument got stuck, you have to use and repair it. And you need to find out each and everything that is related with your laboratory. Very, very important. People miss this. And they depend on, the laboratory personnel. Yes, you have to depend on to learn, to know the procedure. But if the person is on leave for 1 week, you'll stop working. Suppose if you are working with the instrument, if you don't know how to repair it or how to use a particular tool, so you'll stuck for a month or 2 months. If he doesn't come, you don't progress your research. So that is why it is very important to list out each and every instruments, materials, equipments which are needed for your research problem, and then try to understand how the material works. Is there any safety precautions you have to take, and which are the instruments you are using? What is the thorough understanding of operating the instrument and the procedures and everything is very important. So the previous one I was mentioning is his name is Dagalan. He's a carpenter and also undergrad student. So I've taken a lot of help from him to know about various tools and everything. You have to check for alternatives, very important. Suppose some of the instrument you may not get it, but for the same experiment at site, they may use a different instrument, small instrument. It is worth of 2,000-3,000. This is like 70,000-80,000. So you have to quickly purchase that instead of spending 70,000-80,000. You can look for alternative where you can get it for 2,000-3,000, because mixing doesn't alter the mix. It may, but in this case, so you have to see that without affecting the material or the product, you can choose the alternatives, better alternatives. So that will become your one of the research outcome, wherein you can use. If you can also compare both the methods or both the way of usages. This is a civil engineering problem wherein this instrument is generally used for soil testing. We have used it for concrete. What does that mean? See, there are a lot of instruments in the line. Can we test a new material with this particular instrument, or your material, try with that, and test something? So that's what I mean to say. Fabrication is very, very important, and most of the experimental works, technological, engineering related, science related, you have to, if you come out with a nice, idea about a particular method, or you have to fabricate. So you need to know about how to do it, fabrication. In this particular concrete, initially, when we wanted to see through, so we made it using the perplex sheet. So that when we are pouring, we are measuring the viscosity of the concrete. In the second case, actually, we made it using the steel, because this is not coming for number of experiments. So this got failed after some time. So we made it with a metal sheet. So you have to see, fabrication is also a very important part of your research work. These are some of the mixes we've used. So some of the common mistakes: outdated material. If you use it for your research work, the whole work you're doing is a waste of time. I'll just give you an example, civil engineering problem. Usually they bring the cement for the PhD work and then they store it for the number of months. So each month, the loss of strength will be there. What I mean to say is the shelf life of each material you should know. So when you have to carry out freshly, you have to bring the material and do it. Because site, you will use fresh material, right? So similarly, anything, drug or the medicines, okay, you have to check the expiry date. So what I mean to say is when you're making the formulations, and then you make it and you keep it. Sometimes in chemistry, they make formulations and they keep it and they use it after 1 week. It doesn't have any value. So you have to avoid some of the common mistakes while collecting the material, storing the material, and checking the shelf life of the material. So you have to carefully follow that. As I mentioned in the initial presentation of my talk, it is very, very important to make site visits so that you will come to know. So I'll tell you example. Usually we use bricks for our building. Nowadays, if you go to any of the sites, they use solid concrete blocks, sometimes AAC block. So things are changing. But if you take up a problem with the brick itself, because outside, inside, they're changing. So what I mean to say, I'm just giving an example. I'm not comparing which is better, which is not. So what is happening outside, you will come to know when you visit various sites. Accordingly, site-based problem you have to take. That's what I meant. When you take up any research problem, it is very important to conduct laboratory trials. After that, to check the feasibility, you have to go to any of the site and do the full-scale trials. Very important. So for this particular case, solid concrete block, we made laboratory trials, and after that we went to field and carried out the trials. One of the students worked, and then carry out the trials, casting at the site, and bring back the material for testing to the laboratory. What I mean. So it is very important whenever you make any product or whenever you have come out with some kind of process, check in the laboratory. The same thing, convince someone at the site, and then, or the actual ground level, and then, carry out the work at the site also, so that you have a strong backup for your thesis. Okay, this is also tested at site, so it is a good research work which can be useful for the society. So you get a good kind of appreciation, and you also feel happy. So coming to the almost last part of my presentation, This is about the report. Report is the toughest part. Many people are very good at doing experiments, conducting experiments, noting down the results. They don't know what to do with those results. So it is the toughest part. And what you have to do, you have to write what you have carried out on your own words. Again and again you read it, what you have written. You have to practice a lot on your own. Writing your methodology. Write 3-4 times. If you don't feel good, so if you are satisfied yourself, then only you send to your supervisor. Then he'll correct it and send you back. Don't send, just copy paste and dump it in the paper and then send it to the supervisor. Supervisor will get it, because we know, like, how to. This is a cooked up thing or own written. Supervisors will be happy if you write it own. If you are satisfied, means it is properly readable, and it is convincing some meaning. If you want to know the style of writing, then you refer the conference papers, journal papers, how they are presenting various results. And then before writing, you present your work in some of the national and international conferences, part of the work, wherein you get a lot of good feedback that gives a lot of boost. Suppose if you get a lot of questions, that will become your gaps in your research work. So those gaps you can fill it up quickly and then submit the final one. So this will help you to revise or refine and then improve your research work, what you have carried out. So typically report varies at different places, but generally a report having a cover page, and then again the cover page will be there once you open the book, and then your certificate and then acknowledgements, and then list of tables and figures, and then abstract or summary of all the work, and then indexing, and then you have like chapter 1, 2, 3, 4, 5. And each chapter I mentioned, you have to make the summary of each chapter, and then at the end, the conclusion part and future work, future scope, and then the references, and then last your biodata will be there, and then published papers you have to attach. This is how the report you have to write it in the format. And then always, the tables, particularly the table title, you represent above the table. This is what I want to mean. And then nice, comparison you have to make while based on the results. The comparison also very important. And then usually figures or pictures, the figure title comes below the picture. This is the comparison between different conditions of a particular product. Okay, very important. So figures, always titles come below, tables above, because most of the time you represent using pictures and tables. So what are the general expectations from the research student? So what research student follow? What supervisor expects? I would like to give a few points. You have to maintain consistent working hours daily. You have to keep. So everybody having problems, everybody having occupied with the different things. Personal life will be there, your professional life will be there. On top of that, you have to do your research. You have to submit your thesis. So in a day, how many hours you are spending? Initially, you can at least an hour daily. What is the objective of the day? Have you sum up the weekly and then intimate to your supervisor? Sir, last week, this is the every hour I worked this. This is the summary. This is what. If not once in 2 weeks, if not once in 3 weeks, or if not at least a month. So you have to, sometimes your supervisor calls you or mails you, you have to respond the communications from your supervisor. And you have to maintain regular contact with your supervisor. Very important. Supervisor will be busy. He'll be having 2 more students, masters, bachelors, other works, other projects, consultancy works, regular academic work. On top of that, you should maintain. If he is not responding to your phone, put a message, send a mail, gentle reminder, sir, like that. And many times I observe your thesis period is say 5 years. After 4 years, 9 months, you prepare the draft and you give it to supervisor. So supervisor, he will be having a deadline. What is that? 3 months. Sometimes just before 1 month you give it. So you have to provide sufficient time to supervisor. The supervisor will expect you provide sufficient time while submitting. So that what happens, he can take 1 by 1 chapter thoroughly. Each page he can go through and then can give you suggestions. And sustaining the progress in the research work is very, very important. It is not like, the first 3 months you worked hard and then one year you vanished into somewhere and then suddenly comes back after 1 year and again starting. No. You have to maintain the progress. Very important. As I already mentioned about the maintaining safety codes in the laboratory, I've showed with examples, good photographs. It is very important because we expect. Are we following the codes? Are we following the are we following the safety processes in the laboratory? Coming to the quality and structure of the thesis, there should not be any plagiarism. That means you should not copy, paste. Literature review, rewrite what is there. Don't do any cooked up things. No fabrication in the thesis. Very, very important. People can easily find out what is the quality of the thesis based on your plagiarism and whether you have fabricated or not. And you have, after taking up the coursework, you are presenting maybe every 6, it depends on university, every 3 months, every 6 months, sending the report. Whatever suggestions that comes from various people, you have to take it and discuss with your supervisor. And then you have to incorporate those suggestions in the final form of the thesis. Very, very important. Many times, because he's because purposefully they may be saying that's why let us avoid this. No. Try to thoroughly discuss the suggestions, whoever they made, with your supervisor. Then come to an understanding, and then whether we can carry out further, take up this suggestion and do some studies further. Do the studies and incorporate those changes. People will be happy. Because most of the time in your presentations, monthly or yearly or final, so same people will be there most of the time. So you have respected the views, or otherwise at the end of the thesis when you're defending this is what I have suggested you long back, then you have to politely say that, sir, we understood your suggestion, but because of these reasons, it may not be suitable here. That is why we have not done it. And as I mentioned in the thesis, you have to start with an introductory summary. Very important. Combine all the chapters. And so introductory summary is like, if somebody, whoever, even not the subject expert, reads the summary, this is about, this is the output. Even the general public can understand. That kind of summary you have to come up with. And size of the thesis, sometimes 300 pages, even 100 pages, 400 pages. It depends on your subject, and it depends on your university, and depends on various factors. So it varies. Finally, good research requires the scope and limitations of the work to clearly define, the process to be clearly explained so that it can be reproduced and verified by other researchers in the future. Thoroughly planned design, that is an objective as possible. Very important, it should have a proper objective, and then finally. And these are some of the references. Thank you. This is my email ID and then phone number. Over to the organizers for any questions.
Thank you, sir. And we have come to the end of session 2. And we have few questions. We'll quickly go through the questions. And the first question goes, what are the best ways of identifying the best methodology for engineering and science research? So,
that's what literature review is one of the best way, wherein you have to do thorough literature review, both international and then national, and then you have to find out how the problem they approached in your area. So what are the kind of methods they followed? And based on that, you can compare, because you are basically reviewing like minimum 50 papers in that particular area. So when you compare all that, again, sometimes you choose a methodology or a method. But in your college or in your organization, if you don't have that kind of facility, what you will do? So no point. So you have to see based on the available material, instruments, equipments, and compare various methods. So based on the feasibility of all these factors, you have to choose the right method.
Okay, thank you, sir. And we have another question. Can I get a good journal without article processing fee in civil engineering? Most students are discouraged when they cannot get paid for their accepted article. So the person is suggesting some good civil engineering journals.
Yeah. On your quality of the work and the duration you have carried out. Because many times what happens in particularly civil engineering field, a lot of experimental work you carry out. If it is a repeated work already carried out, so you will come to know the quality of your work itself. Suppose something new, if you come out, it is very important to send it to various journals, get the feedback. Sometimes, you will send it to a particular journal, maybe without fee. Okay, but they will send a lot of comments. If you can answer the comments within 3-4 months by carrying out a little bit of experimental work, definitely they will accept one second. So there are a lot of journals that are available globally, even in India. Okay, one can, it depends again on the quality of your research work you have carried out.
Thank you, sir. With this, we come to an end of session 2. And thank you for joining us today, sir. Thank you so much for your very informative session. And thank you, everyone. And if you have any questions related to the session 2 or our webinar series, you may write to us at webinar@iferp.in. And do follow us on Facebook, Twitter, LinkedIn, and Instagram for upcoming events. Thank you so much. And thank you, sir. Good day.
Thank you.